4. Range and penetrating power. Range is the distance that a radiation can travel in a certain medium. For example, alpha radiation can travel typically 5 cm in air, and so its range is 5 cm in air. A GM counter is a GM tube connected to the digital counter. It is used to measure the count rate of radiation, which is the number of counts per second. Using a GM counter, we may measure the range and penetrating power of a radiation accurately. To begin with, a GM counter is used to measure the Big Bang count rate. In Hong Kong, the Big Bang count rate is about 100 counts per minute. Then, the count rate of a radioactive source can be measured by corrected count rate, equals the measured count rate minus the Big Bang count rate. Now, let's see how we may use a GM counter to measure the range and penetrating power of radiation.
This is a Geiger-Müller tube, or GM tube for short. It is connected to a counter to become a GM counter. The GM counter is used to measure the counts or the count rate of radiation at a certain position. There is no radioactive source near the GM tube now. Why are counts recorded? A gas mantle is held in front of the GM tube. What does the count record tell us about the gas mantle? A radioactive source is placed in front of the GM tube. The counter records a large number of counts. The sound from the loudspeaker gives an indication of the count rate. When the radioactive source is close to the GM tube, a high count rate is recorded. Why does the count rate drop when the radioactive source is farther away from the GM tube?
To measure penetrating power, we insert different materials until the GM tube reading drops to the same as the background radiation. To measure range, we move a source away from the GM tube until the reading again drops to the same as the background radiation.
We will compare the penetrating power and the range of alpha, beta, and gamma radiation using a GM counter. Before conducting the experiment, we will first measure the background radiation. Connect a GM tube to a counter. Set the voltage of the counter to 400 volts. Make sure there is no radioactive source near the GM tube. Measure the total number of counts in 1 minute. Calculate the count rate in counts per second. This is the background radiation. To obtain the corrected count rate of a radioactive source, that is, the count rate due to the source only, place the source in front of the GM tube and measure the total number of counts in 1 minute. Calculate the measured count rate. Then subtract the background count rate from it. The result is the corrected count rate. We will start the experiment with an alpha source. The source is now placed 1 centimeter in front of the GM tube. Insert a piece of paper between the source and the GM tube. Note the change in the count rate. Insert more pieces of paper until the count rate drops to the background count rate. Remove all the papers. Slowly, Move the source away from the GM tube until the count rate drops to the background count rate. Measure the distance between the source and the GM tube. This is the distance the alpha radiation travels before it is completely absorbed by air. It is called the range of alpha radiation in air. Now try a beta source. Place the source 5 centimeters in front of the GM tube. Insert aluminium sheets between the source and the GM tube until the count rate measured drops back to the background count rate. Remove the aluminium. Slowly move the source away from the GM tube until the separation between them is 50 centimeters. Does the count rate drop to the background count rate? Lastly, try a gamma source. Put the source 5 centimeters in front of the GM tube. Insert lead sheets between the source and the GM tube. Does the count rate drop to the background count rate? Remove the lead sheets. Slowly, move the source away from the GM tube until the separation between them is 50 centimeters. Note the change in the count rate. Among alpha, beta and gamma radiation, which one has the strongest penetrating power, and which one has the longest range in air?
The gamma radiation has the strongest penetrating power, while alpha has the least.